All right, for question 18, it is a question about more about equations you learn in S5 chapter 1 and some sine, cosine, basic trigonometry you learn in S4, all right? So first part, we ignore the complicated trigonometric thing first. Let's just solve A, alpha, and beta using more about equations you learn in chapter 1, all right? So part A, so you can actually isolate B, right? These two are equal, so you can actually write 5 alpha minus 12 equals to alpha squared minus 7 alpha plus 24, all right? Alpha squared minus 12 alpha plus 36 equals to 0, all right? So afterwards, you can actually solve this quadratic equation using quadratic formula, or you can use the calculator program. You can obtain that one alpha is equal to 6 repeated roots, all right? So better write down alpha minus 6 squared equals 0, alpha equals to 6 repeated, all right? So no matter what, alpha must be 6, all right? So substitute alpha equal to 6 into, say like beta equals to 5 alpha minus 12, all right? Beta equals to 5 times 6 minus 12, which will be equal to 30 minus 12, which will be 18. Therefore, you can calculate that alpha equal to 6, beta equals to 18, all right? This is the solution for part A. And for part B, all right, so you can, after you know the values of beta, alpha, then you can directly substitute that 18 sine square theta plus 6 sine theta cosine theta minus 4 cosine square theta equals to 0, right? All right, so if you cannot think of it, then just think of some ways that you can basically simplify it first, okay? So let's reduce this formula, do some factorization, all right? You can see there are multiple of 2, so you can actually divide by 2, right? 3 sine theta cosine theta 18, it will become 9 sine square theta plus this, all right? Then how can you do it? All right, so actually, can you imagine that let like sine theta be A and cosine theta be B? So is this in the format like 9A squared plus 3AB minus 2B equals to 0, right? So actually, you can factorize it, right? How can you factorize them? It will be 3, for say like 3, all right, and then minus 1, and then plus 2. Then it will turn out negative 2b, 3a, negative 1b, 2b, and you can also obtain the same output, right? Yes, so you can actually use this method to factorize it into 3 sine theta minus cosine theta times 3 sine theta plus 2 cosine theta, all right, equals to 0, all right? This is the method you need to know, okay? So then you can separate each one, all right? So this one, 3 sine theta minus cosine theta equal to 0, or the second one, or 3 sine theta plus 2 cosine theta equals to 0, all right? 3 sine theta equals to cosine theta, 3 sine theta plus, all right, equals to negative 2 cosine theta, all right? All right, so how can you simplify sine theta and cosine theta? Do you remember a trigonometric identity you learned in S2? A trigonometric, some common trigonometric identities, which will be how can you connect sine theta and cosine theta? We can use tangent theta equals to sine theta over cosine theta, right? All right, so actually it's very simple. 3 sine theta over cosine theta equals to you can divide both sides by cosine theta, then you can obtain 3 tangent theta equals to 1. Tangent theta equals to 1 over 3, right? All right, so, and let's look at the second part first. Divide both sides by cosine theta so that you can obtain the trigonometry sine 3 tangent theta equals to -2, tangent theta equals to -2/3. All right, so tangent theta equals to, okay, so let's pay attention to tangent theta. Tangent theta equals to 1/3 ASTC. So theta you can obtain by the calculator is 18.4 degrees, all right? Tangent, yeah, 18.4 degrees, okay? But also in the tangent part, it will also be positive, right? But it is beyond the range because look at the question. The required range is only 0 degree to 180 degree. Lying on this part is talking about 180 degree to 270 degree already, so it is to be rejected. All right, so and the second one will be theta equals to -2/3. What is the negative range here and here, right? So the value lying on C ring on the C area should be rejected. So the value of theta should be equal to 180 degree minus, okay, 33.69063. So the answer should be equal to 164 degree correct to significant figure. Okay, this is the solution of the theta. All right. And for part C, it is about some in some big numbers, right? Fx equals to this. Okay, so do you have a sense? 4 to the power of x, 2 to the power of x, you can actually, by using the technique you learn, equations reducible to a quadratic equation, you can actually form a quadratic equation, right? Equations reducible to a quadratic equation. This is the most common technique in solving higher degree equations, logarithmic equations, polynomial equations, okay? So you can actually use this method, and let me first plug in the value again first. Fx equals to 4x minus 4 to the power of x minus alpha is 6, alpha is 6 times 2 to the power of x plus 18, all right? So how can we solve? Okay, so this one is larger than, so we can know that 4 to the power of x minus 6, this one is larger than 5 times 10 to the power of 3. Okay, so you might need to use another technique you learned in chapter 2, which will be solving quadratic inequalities. Quadratic inequalities are something very typical to appear in section B because it can assess your knowledge in solving quadratic inequalities. Okay, so how can we simplify this? Firstly, equations reducible to a quadratic equation. It will be 2x minus it will be 2x squared. Why? Because let's look at this. It will be actually equals to 2 to the power of 2 times x. 2 to the power of 2x. So you can 2x squared. All right. So by this one, you can obtain a quadratic, right? And this one will be equal to this one. All right. So 2 to the power of x squared, this one, plus 18 is larger than 5x, this one, right? Okay, so then you might have to consider moving it into the same side in order to solve the quadratic inequality, right? 18 minus 5, this is basically 5,000. So negative minus 4982 is larger than 0. Okay, so this must be positive and negative. So you can actually draw a curve like this using the quadratic inequalities method. Okay, so and then solve this equation. All right, what is larger than 0? Solve this equation. So you can actually obtain that 2x. So this part I will regard it as rough, okay? Do it in your reference sheet, okay? Don't write it in the officially here, okay? 2x, use the program solving the quadratic formula. Type 1 minus 6 minus 4 0.00982. So you can obtain that 2 to the power of x can be equal to 73.64700,984, or 2x equals to negative 67 point this a bunch of thing, okay? And then you can, this kind of rough work, okay? And then you can plug it here, okay? So this is 73.6, this is negative 67.6. All right, so larger than 0, right? The question requirement is larger than 0. So the range should be larger than 0, larger than 0, all right? Therefore, you can finally write down 2x should be smaller, because you can see beyond this it is smaller, right? For the left hand side, smaller. So 2 to the power of x is smaller than negative 67.64700,984. Okay, this should be rejected because anything, this one, it will not, the range will not be less than 0. All right, if it is negative, then it should be rejected. Or second part, for the right hand part, 2 to the power of x is larger than 73.64700,984. All right, this one is solvable. All right, so how can you solve it? Basically, when you see index powers, then you should actually take log. Okay, log. Okay, so it is, and then you can move this x to here, x log 2. Okay, so x is basically larger than log 73 point this one divided by log 2. Okay, so x is larger than, let me use the calculator to calculate, divided by log 2, x is larger than 6.6 at 6.20. Okay, remember the question is asking about the largest integral value, so it should be an integer. So in the concluding statement, you should say the least integer is 7. This will be the final answer for this question.